Hey, pre-algebra students. I'm going to work through some examples, or I guess talk through some of these examples on the progress packet here, so hopefully that can help you out if you have some questions. All right, number one, pretty self-explanatory. You can just Google the definition, basically, if you need to. 2 and 3, you want to make a stem and leaf plot of the data. Now, what you kind of want to do when you're making stem and leaf plots, just to reiterate, is, especially when you're working with 3-digit numbers or however many digits, you want everything except the last digit to be to the left of this line that you're going to draw. And then each digit after that represents a distinct number. So this, and make sure you look at the key here, so 31 and then a line and 5 indicates 315. So then really you just make your list, go make sure you cover all the tens places for every digit all the way up to the highest one. And then just show the amount of times that number occurs. Well, 300 occurs once, 306, 309, so on and so forth. Just go through and fill them out. Don't let the decimals in this one throw you off. You just still want to do the same thing, but just make sure in your key what you're doing here. So 335 and then a line dash 0 indicates the number 3.50. So still treat that last digit and put that to the right of the line and put every other digit to the left of the line. It just looks a little different, but it's the same concept there. Okay, now when you're making a frequency table into histogram, make sure your values that you're choosing are equal. So 1 to 2 is a space of 1, 3 to 4 is a space of 1, 5 to 6, so on and so forth. Make sure that these values you select are all equal. Don't be doing 1 to 2 and then 3 to 6, right? You want all of the increments to be the same. That way it's not a misleading chart. Okay, so make sure you categorize them all correctly. Just count the total number of tallies. That one's not too bad. Okay, in 11.3, what you want to do here to tell whether the data is numerical or categorical, if it's numerical, they're recording numbers, and if it's categorical, they're telling you categories of things. So just keep that in mind. Numerical is pretty easy to identify. So for example, 7, a coach recorded the number of goals scored by each member of a hockey team. That would be numerical. Now, to tell which type of data display, there could be multiple answers for this. Just make sure you explain your reasoning somewhat thoroughly. So I argued that this is a numerical, they're recording the number of goals, so it's mostly numerical, but you could make it categorical, sort of, if you were categorizing the players themselves, saying Tim scores this many, Jim scores that many. But it's really more numerical than anything else, which means you should probably use a histogram. I would argue maybe a bar graph would be a good thing to represent, because you could say Jim scored this many goals, Tim scored this many goals. So there's a couple of ways you can go with that one. Let's see. For 9 and 10, tell which data display. So basically the same thing. Just keep in mind, the median of a data set, the best thing for that is a box and whisker plot, because it tells you the exact median. And then kind of just use logic on the rest of those. Check out that PDF that was uploaded for that section. For number 11, 20 people, we'll go through 11, A and B. 20 people were asked to state the number of hours per week to exercise. The frequency table shows the results. Is the frequency table misleading? Well, at first it doesn't seem like it'd be misleading, 0 to 2 hours, 2 to 4 hours, but then it goes 4 to 8 hours and 8 to 16 hours. Since the interval's here, let me get my highlighter, maybe. Don't know why that's not working. Interesting. But since the intervals 4 through 8 and 8 through 16 are, well, not the same amount as the same distance as 0 to 2 and 2 to 4, that's going to lead to some misinformation. Because, well, if the range is wider, you're going to have more possible people that would fit in that range, which is why the frequency more than likely is higher towards 8 to 16 and 4 to 8, just because it includes more values that people could be choosing. All right, there we go. So these two values have different values than 2 to 4 and 0 to 2. This one is a 4-hour range. This one's an 8-hour range. So that's why it's misleading. Okay, what conclusions can you make? Well, you could say that most people exercise between 8 through 16. That'd be a true statement. However, the intervals are a little misleading, so there's not a lot of useful information in that, I guess, or at least clear information. Okay, now 11.4, working with population samples, different types of surveys, that kind of thing. Remember, a population, it's the entire member, like it's like the entire group. It's all members. So A sample is something you basically take from a population. A sample is just a subset representative of a population. That really just means a sample is just a small chunk of a population that you use to analyze and then make statements about the larger population, because it's easier to gather information from a few people or a few things than it is to gather information from a lot of people or a lot of things. Okay, so keep in mind there's random sampling, systematic sampling, stratified, convenience, self-selected, those kind of things. You kind of have to think logically. A lot of these you could maybe think up maybe two types of sampling methods that it's close to. Choose the one that it best fits. So in example 14, they set up a booth where students can come to give their opinions. So a lot of people might think, well, that's a convenience sample, right? They're just setting up a booth and getting somewhere relatively easily. But you have to think about what's going on here. They're setting up a booth, and then students are coming to give their opinions. They're not going out and asking students themselves. This is completely self-selected. The students are coming on their own accord to give their own opinions. So that's why it would be, the best example would be self-selected. Okay, now 16, I would argue, is probably the one that can most arguably be two different things. They interview every third student as students leave the school. That is a good example of systematic. It's also sort of a convenience sampling method as well, since they're just getting kids as they leave the school. But it's more systematic because there is kind of a rule that's going on. They're taking every third student. All right. So, number 20, a researcher wants to know the opinions that people in a state have about filling out surveys. The researcher asks the first 30 people who volunteer to take a survey, do you think surveys are a useful tool to gather information? So what we want to do here is tell what the type of population is, and then tell whether the sample is likely to represent the population. So the population is the people in a state, right? If that's what the researcher wants to know, then the people in the state would be the population. Now, he's taking a chunk of the people in the state. Very clearly, you can't go around and ask every single person in a state survey questions. Okay, but there's a couple problems with this. He asks the first 30 people who volunteer to take a survey. So that would be just a self-selected sample. It's just people who volunteer to take a survey. So that's one problem. Self-selected samples aren't great for accurate information about a general population. And the reason for that is, well, in this example, do you think surveys are a useful tool to gather information? If you're going to just take the first 30 people who volunteer to take a survey, the type of people that volunteer to take a survey are probably the ones that think that they're useful. So there's going to be bias in that. So be wary of those types of questions. Understanding where biases can occur can either be in the way the information is gathered, the way the question's posed. There's various things that could be wrong. All right, now our last section was margin of error and then making predictions. Really the most important thing was understanding how to make predictions. So, example 22, a survey of 200 randomly selected dog owners finds that 130 dog owners prefer brand A dog food. Predict how many owners in a town of 1,500 dog owners would prefer brand A dog food. So what you want to do here is, well, basically take that sample percentage. Well, they surveyed 200 people. There's 200 total people. Of those 200 total people, 130 preferred brand A dog food. Well, that percentage is going to be, plug that into my calculator, 130 divided by 200. I get 0.65, which is 65%. So 65% of those people that were surveyed preferred brand A dog food. To make a prediction about the general population is you then take that percentage and multiply it by however many people there are. So there's 1,500 dog owners. We want to predict how many prefer brand A. Well, just take 0.65 or 65% times that, and you get 975 owners. So that's how you do these types of problems. Find the percentage of the sample, and then just use that percentage, multiply it by the total population you're looking at there. All right, last thing. So basically we take this idea of a margin of error. It's just how much a survey could fluctuate. So in example 23, a newspaper surveys a random sample of 200 voters with a margin of error of 7 plus or minus 7%. Of these voters, 88 plan to vote for candidate A and 112 plan to vote for candidate B. Can you predict the winner? All right, so this one's kind of structured for you. Let's move. You should just be able to work through these. Find the percent of voters who plan to vote for each candidate. Well, it's just taking however many out of the total, and then you'll find your percentage there and kind of work through those. Those are pretty self-explanatory. Number 24 is where you really want to look at these things and then use the margin of error. So the margin of error is given for each thing. This is a distinct one. This next one is a distinct survey, so on and so forth. So what you want to do here to see whether it's a good survey or whether you might be able to make a prediction is take that percentage for each candidate. The leading candidate has a 56% vote turnout in the sample, whereas the trailing candidate has a 44% turnout. Now, in that particular survey, there's a margin of error of 3.5%. That means that realistically, this 56%, there's going to be a range. You want to add and subtract 3.5 from that. So if we subtract 3.5 from 56, you're going to get, you subtract 3.5 from 56, you're going to get 52.5. And if you add 3.5 to that, you're going to get 59.5. So really, the leading candidate has, well, at least 52.5% to 59.5% of the population will probably vote for him based on that survey. Whereas the trailing candidate, well, we could subtract 3.5, we would get 40.5%. We could add 3.5, we get 47.5%. Okay, is there any overlap there? And since there's no overlap, the highest this one is going to get is likely 47.5% of the vote. The lowest the leading candidate's going to get is 52.5% of the vote. There's no overlap there, so you can somewhat confidently predict that, hey, the leading candidate is going to get the mayoral position. Okay, now, a different example would be the treasurer. So if we look at the treasurer, we have the leading candidate at 53%, leading candidate, trailing. The leading candidate's at 53%, and the trailing candidate's at 47%. But there's a margin of error of 4%. So we could go anywhere from 49% with the leading candidate all the way up to 57% of the vote based on that survey. Whereas the trailing candidate could receive 43% all the way up to 51% of the vote. Now, the trailing candidate could get 51%, it could get 50%, and the leading candidate could apparently get 49 and 50, or could also get 50 to 51%. Since there's overlap, you cannot confidently predict who's going to win. This one would be too close. So basically, using those two strategies, you should be able to figure out the sheriff and the controller as well. All right, hopefully that kind of helps you out. Make sure you're jumping on some Zoom videos or emailing me if you have any questions and that you're ready to go for this quiz on Thursday and Friday. All right, have a good day, everybody, and as always, stay safe out there.